We've been talking about matter. Well, the most basic unit of matter is the atom. So now we're going to talk about models of the atom, and really one in particular. But before we get into the model of the atom, we're going to review what an atom is and matter. Now remember, we defined matter as anything that has mass and takes up space, or anything with a mass and a volume. Now all matter is made up of atoms. Atoms are basically considered the building blocks of matter. It's kind of like how the bricks in a house are the building blocks that build that house. So now that we know what an atom is, we need to know a little bit more about the atom. Now there are 3 parts of an atom that we need to be concerned with. First of all, there are the protons. The protons are the positively charged particles that live inside the nucleus of an atom. The neutrons are the particles that have no charge, or they're neutral. These are also inside the nucleus of the atom. Now electrons, they have a negative charge. And these actually orbit the nucleus of the atom. So protons, neutrons, and electrons. The proton is positive, the neutron is neutral or has no charge, and the electron is negative. A lot of times I'll abbreviate these, proton with a P and a plus sign, neutron N with a 0 for no charge, and electron E with a negative sign. So we can find the protons and the neutrons inside the nucleus of the atom. So right here in the center. The positive signs are the protons, the ones with no charge are the neutrons because they're neutral. Now the electrons are the much smaller subatomic particles that are outside the nucleus, and they are orbiting the protons and neutrons, the nucleus. So the key things to remember, an atom has 3 subatomic particles: protons, neutrons, and electrons. Protons are positive, neutrons are neutral, electrons are negative. Protons and neutrons live inside the nucleus, electrons orbit that nucleus. Also, electrons are significantly smaller than protons and neutrons. Now that we know what atoms are, what are elements? Well, elements are the alphabet to the language of molecules. So what that means is that elements are the things that we put together to make molecules. Just like letters are the things we put together to make words, right? To make molecules, you must have elements. You can't have a molecule without elements. Now, elements are made up of atoms. When we talk about elements, one element is made of only one kind of atom. Now, atoms may have different weight and different organization, but they are all built in the same way. So what that means is that all atoms are made of protons, neutrons, and electrons. And they all have protons and neutrons in the middle of the atom in the nucleus, and they all have electrons outside. But because they have different numbers of protons and neutrons and electrons, they're going to behave very differently. Elements are the building blocks of all matter. So atoms make up elements, elements make up molecules and compounds. Now the periodic table is a list of where we can find all of the different kinds of elements that we can use to build matter, or that we have, that makes up matter. So I know when I say this, you're going to think I'm crazy. But the periodic table is one of the coolest tools there is in science. And that's because it's so amazing and so useful once you figure out how to use it. Now, you're not going to need it too much until you get to chemistry, but for now, we're going to talk a little bit about why it's so cool. Not all periodic tables look the same, but they all have the same general information. So when you look at a periodic table, there's always boxes with different elements in them, one for each element. One of the first things you're going to notice on the periodic table is the symbol that's here in the middle. This is the symbol for the element. This is the abbreviation for the element. It's always going to be a letter, or maybe 2. If there are 2 letters, the first letter is always capitalized and the second letter is always lowercase. If there's only 1 letter, the first letter or the only letter is always a capital letter. The next thing that you're going to see when you look at the periodic table, most of the time, is the name for the element. All that is the element's name. Depending on the periodic table, you may not find the element's name, but generally for this class, you will. Next thing you'll notice is there are 2 numbers on the periodic table. There's the smaller number and the larger one. Sometimes you're going to see the smaller whole number at the bottom, sometimes it's in a corner, but either way, this smaller of the 2 numbers is the atomic number. The atomic number is the number of protons in the atom. It's also the number of electrons in the atom. The other number on the periodic table is the atomic mass or the atomic weight. On this particular example, it's a whole number. It's not always going to be a whole number. But what this tells you is the number of protons and neutrons combined. So you can use a combination of the atomic mass and the atomic number to calculate the number of neutrons, but we'll get into that in a minute. We'll be using 2 different models of the atom in class. The first is the Bohr model, the second is Lewis dot structures. Let's start with the Bohr model. The Bohr model shows all of the subatomic particles in the atom. In the center of this model is circles. Each circle represents a single neutron or proton. Protons should have a plus or a P written on them, mostly so we know that they're protons. Neutrons should be blank or have an N on them. In a circle around the nucleus are the electrons, and these should have a minus sign or an E so that we know they represent electrons. And like I said before, I usually use an E with a minus sign. Let's look at a quick example of the Bohr model. So if we have an element like helium, helium has 2 protons and 2 neutrons. It also has 2 electrons. So I'm going to draw my protons and my neutrons in the center of the atom. So my proton is going to be this black circle. Got to put the plus in it. So there's 1. And here's 2. I also need to have 2 neutrons. I can leave that blank, or I can put an N in it. So here's my other neutron. Then I'm going to have my outer shells where I have my electrons. So outside my nucleus, I have these rings. We'll explain those in just a minute. In that first energy level, or that first shell, I am going to have my electrons, and I'm going to use blue for those. So I have 1, 2, and remember I need to draw the minus sign on that so that we know that those are electrons. So this is what the Bohr model looks like for something like helium. We'll try some others in a minute. All right, electrons have special rules. We're not able to just put all of the electrons into the first orbit of an electron. An orbit is what I called an energy level, or those rings that are around the nucleus. It's called that because in the Bohr model, the electrons orbit the nucleus, kind of like the planets orbit the sun. So electrons live in something called shells or energy levels. And like we said, we can't just shove all of the electrons into one of those orbits or energy levels. Only so many can be in any certain shell. The electrons that are farthest away from the nucleus, that are in the outermost shell of any element, are called valence electrons. So when we're putting electrons into our model, a couple things you have to keep in mind. First thing is the center of the atom is the nucleus. So since that's the nucleus, we don't have any electrons there. It's only protons and neutrons. After that, our first energy level, our first shell, is going to hold up to 2 electrons. It won't hold any more than that. If there's more than 2, they're going to overflow into the second shell. That can hold up to 8 electrons. Once that one's full, we're going to overflow into the third shell. And that third shell can hold up to 18 electrons. Let's try an example. If we're going to draw the lithium atom, the first thing we have to do is look at the periodic table. Second, we have to determine the number of protons. Then we can determine the number of neutrons. And we do that by looking at the atomic mass and the atomic number. Remember, the atomic mass is the larger of the two, the atomic number is smaller. Atomic mass minus atomic number gives us the number of neutrons. The next thing we have to do is determine the number of electrons. We can find the number of electrons by looking again at the atomic number. Remember, that's the number of protons, and it's the number of electrons. Now we're ready to draw lithium. So remember, the first thing we do is look at our periodic table. When we do, we're going to see something that looks like this. Next thing we do is figure out how many protons we need by looking at the atomic number. So the atomic number is 3. That tells me that I need to draw 3 protons. I'm just going to make a little list over here. Okay, the next thing I need to do is figure out the number of neutrons. I'll do that by looking right here at my atomic mass. Remember, atomic mass is protons plus neutrons, so that tells me that my protons and neutrons together give me 7. So to figure out the number of neutrons, I'm going to take 7 and subtract the number of protons that I know I have. So 7 minus 3 is 4. So I need 4 neutrons. All right. The next thing I need to do is figure out the number of electrons that I'm going to need. That's also going to come from my atomic number up here. So now I know I have 3 electrons as well. Now I'm ready to draw. So inside my nucleus, I'm going to include my 3 protons. So 1, 2, 3. Remember, we also need to put a plus sign inside of each one of those. So I have 3 positives right there. Also inside my nucleus goes my neutrons. So I'm going to make my 4 neutrons, and I'm going to make them blue. And we'll put the 4th one there. Now my nucleus is done. We don't have to label our neutrons, but you can put a N inside of them if you need to. Next thing I need to do is look at my energy levels. I know I'm going to have one energy level that's going to hold my first 2 electrons, but then I'm going to have an extra electron I need to put somewhere. So I'm going to need a second energy level. So I've drawn my 2 circles, and I can always add more if I end up needing them. So I have 3 electrons. The first one is going to go in the first energy level. The second one's going to go in the first energy level. Now notice I'm not drawing those right next to each other. Electrons don't want to be close to each other, so they get as far away from each other as possible. Now I have 2 electrons in that first energy level. I have no more room for a third one. So my third one's going to go out here into the second energy level. So I'm just about done. All I have to do now is put the minus sign in my electron so that I can remember that they're negatively charged. And I know they're electrons. And there you have the Bohr model for the lithium atom. The other model we need to look at is the Lewis dot structure. This is a little bit different from the Bohr model. The Lewis dot structure shows only the element symbol and its outermost electron shell, or valence electrons. So let's look back at our example of lithium in the Bohr model. Remember when we drew this, we had only 1 electron in that valence shell. So when we draw the Lewis dot structure, the first thing we're going to do is write the symbol, which is Li, and if you can't remember that, just look up here at your periodic table. The next thing we need to do is put our valence electrons around the outside. Now the most we can ever have is 8. All right, so we're going to put this 1 right here at the top of lithium. Now remember, if there's more than that, we want to spread these out as much as possible. So you might go top, and then the bottom, and then each side, and then you can start to pair them up again until you have 8. But you should never have more than 8 valence electrons. So lithium has a pretty boring Lewis dot structure. Let's try one that's got a few more valence electrons. So let's try oxygen. Oxygen has an atomic number of 8, which means it has 8 protons and 8 electrons. Now, remember, it has 8 electrons. The first 2 go into the first energy level, and then the second, or the rest of them, go into the next one. So that means that I'm going to have 2 in the first energy level, 1, 2, and I'm just going to draw this real quick so we can think about it. And then the rest are going to go in the next energy level. So I have 2, 3, 4, 5, 6, 7, 8 total electrons. I have 1, 2, 3, 4, 5, 6 in my valence shell. So I have 6 valence electrons in my oxygen atom. So the first thing I have to do is draw my symbol for oxygen, which is an O. Then I'm going to put my dots, my valence electrons, around the outside for our Lewis dot structure. So I'm going to put 1, 2, 3, 4, and then 5, 6. So this is the Lewis dot structure for oxygen. If you drew it with the O here, and then 1, 2, 3, 4, 5, 6, that's okay too. We still have 8 or 6 valence electrons around our oxygen. Either one of those would be perfectly acceptable.